So when you're combining transformations, what you gotta know is S, R, T. That's really easy to memorize. And that just means stretches, reflections, and translations. So for example, if we get like y equals x squared, and we want to translate it down by 3 units, vertically stretch by a factor of 2, and reflect it in the x-axis by the order of this, or you could do R, S, T. It's your choice. It doesn't matter. You have to make sure you do the translation last. But if you also have to do like a horizontal translation before like a vertical stretch, you can do that because the horizontal translation does not affect the vertical stretch, because the vertical stretch affects the y values. So here's what we can see. There's a vertical stretch of 3, and there's a horizontal stretch of, take the reciprocal of whatever's here, 1 over 2. And there's a vertical translation of minus 4 units. So let's do the horizontal stretch first. Why not? Okay, half of negative 1 is negative half. Half of 0 is still 0, and half of 3, 1.5. Okay, so that's the first thing done. Now let's do and I'm going to do this with different graphs each time so you really understand the steps we're taking. You could do it all at once if you want to. This is just to make it more easy to understand. Now we're going to do a vertical stretch by a factor of 3 because that comes before the vertical translation. Remember? S, R, T. We're going to do a stretch before the translation. So now let's do the vertical stretch. Okay. This on y equals 1 times 3, it goes here. This on y equals 0 times 3, it stays at 0. This on y equals 3 times 3, that's 9, way up here. Okay, now we can translate it down by 4 units. Let me get a purple pencil. So, 0 minus 4 goes here. 3 minus 4 goes here. And 9 minus 4 goes here. So, the purple graph is how our graph looks after every single transformation. The purple graph is our final graph. With this, you can do what I showed you in the 5 seconds ago, but you can also just use mapping notation and just graph the new image of, the new image graph. Let's get the original first. So as we can see here, our b value is 2, and we always take the reciprocal of the b value in the mapping notation or when actually doing the transformation. So that's going to turn into 1 over 2 x, and we can also see that x is going right 4 units. Our h variable is positive 4 plus 4. Alright, perfect. Comma. And then our y values are getting reflected, and they're being stretched by 1/2, so that's our y, and then they're being raised by 2 units. Okay, so that kind of got off the screen. I'm gonna drag it back here. Okay, so now it's more visible here. Kind of looks bad. Let me just make sure it doesn't look like an exponent. Okay, so that's our mapping notation. X, y, arrow, 1 over 2x plus 4, comma, negative 1 over 2y plus 2. Easy peasy. So now we can just take some points. 0, 0, our vertex, is going to turn into 4, 2. 1, 1 is going to turn into 4.5, 1.5. 2, 4 is going to turn into 5. Oh, easy peasy, lemon squeezy. Now let's draw our new graph. Our vertex is at x equals 4, y equals 2, right there. Let me use a different color. That's my bad. Okay, second point, 4.5, so that's like what? Like right here. 1.5, so that's like right here. And it looks like this. So first thing here, the vertex is unaffected by stretches or reflections. So we can just find out where it was translated. So the vertex went 1, 2, 3, 4, 4 units up, and 1, 2, 3, 4, 4 units right. 4R, 4U. Okay, 4 right, 4 up. Now, obviously, this is reflected in the x-axis, so R ref in the x-axis. Sorry, I'm kinda slow speller, and the handwriting looks horrible. And then let's just see what happened. So our first point is no longer here, but it's here. So there's a vertical stretch of 2. Let's verify that. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so VS by 2. Perfect. So G of X is going to be equal to the reflect. It's reflected, so there's going to be a negative in front of the stretch, which is 2 F of X minus 4 plus 4. Okay, so how do you apply transformations to things that are already like kind of transforming? So first, everything that happens vertically is going to be outside. So let's just do our 5 and our plus 1. Because, you know, the stretch here, the translation here, they only affect the y values, correct? So let's just keep them outside. And everything inside, so f of x minus 4, that's going to be our actual function. So 3. And instead of x squared, we have to replace this x with x minus 4, right? Like how we did before, like with everything else. X minus 4 squared plus 2. Okay. Easy enough. So now we just got to distribute it, okay? 15 x minus 4 squared plus 10 plus 1, which makes that just plus 11. Boom! We have the vertex. It's in vertex form. Easy. Easy as hell. Now, how do we deal with this question? There's 2 x's. You do the exact same thing you did last time. You just replace the x's with x minus 4. Okay, so let's keep our vertical alterations, transformations on the outside of this. So 5 y equals 5 plus 1, and then 9 x minus 4 squared minus x minus 4. I'm running out of space here. Oh my god. And then plus 2. Okay. And now let's just distribute it. 45 x minus 4 squared minus 5 x minus 4 plus 10 plus 1. Okay, let's keep going to get this in vertex form. This is x minus 4 squared, x squared minus 8x plus 16 minus 5x plus 20 plus 11. And then that becomes 45x squared minus 360x. That's a 0 plus 720 minus 5x plus 31. And that finally becomes 45x squared minus 365x plus 751.